So let us illustrate further the sensitivity input. So just place your eyes here on this equity value per share. Let me just highlight this to go out edge. Let us change that fill color to orange. So you can visualize that. Let's go out edge FC. Let us make the font white. So let us change this discount rate here to 12%. Just set your eye on that intrinsic value per share, the equity value per share there. As you can see, when we switch things around this model, under the sensitivity input for the discount rate, we can see that it changes to $2.5 million per share. So if you switch this year to, say, 6%, you see that it switches there in the model to $4.6 million per share. If you switch this year to, say, 10%, you can see that it keeps switching in the model, and it's a very nice tool to develop in a model like this. It's really very dynamic. So we can switch this to say the weighted average cost of capital is equal to the long-term growth. Let us switch this to 4%. As you can see, it switches as well. So let's set up. Also remember we had here for the terminal value perpetuity calculations here, we used the go-down growth model to determine the terminal value for the perpetuity growth of these cash flows. So as you can see, we also developed a formula here with an if statement saying that if the WACC, the weighted average cost of capital, is equal to the long-term growth, let it give us this dash. That is 0. Let us just leave that cell to be dash. Why? Because it shouldn't give us a div 0 instead, so that everything else will flow through the model. As you can see, when we switch the cost of capital to 4% to be equal to the long-term growth, it's kicking in here just as we want it to be. So we can just go Alt Edge AR to align that right. And we can just border with Ctrl B, so we can see that it's giving us exactly as we expected. So it's a very powerful tool to find in models like this. So we can do the same thing for the terminal value, EBITDA, base case, and cost of sales. So we can do the same thing for all of those, and you can see that it will just dynamically link to the model. So delete that, and if we switch to, let us set the cost of sales to be, let's say, it used to be, say, 25%, and see what happens. See what happens here. The equity value per share increases massively to approximately $40 million per share because we are reducing the cost of sales. So if you switch this to 30%, we can see what happens. So you can see it's a very powerful tool to find in a model. 25, 50%, it reduces to $7 million per share. And also we have all of those there. So we can also do the same thing for the base case annual growth taper. In this case, if we switch things here to say that, let us say that our assumptions minus the base annual growth taper was 20% from our assumptions. So let us say that it was just 10%. Say that in the very base case, if we reduce the growth in revenue in our income statement, if we say revenue was going to decrease in growth by say 10% instead of 20%, we can see that it increases the equity value per share. So if we change this to say 7%, we can see that it changes as well. In this case, we have our capital growth rate of 20%. So it gives us exactly our base case scenario. So it's very, very powerful to find this in the model. And also, if we switch, if we change things for the terminal value EBITDA multiple, so in this case, it is 25 times if you have to exit in the year 2031 to sell your shares. Let's just say that it is just 20 times. What happens here? We see that it decreases the equity value per share. If we change this to, say, you're going to sell your shares 40 times EV to EBITDA, 40 times EBITDA, so it's 40 times, we can see that it increases the equity value per share. So that's it. And also, it's a very, very powerful tool to find a model like this. So having said that, we can delete that. Now we can move on to our sensitivity analysis. So here we're going to be sensitizing the equity value per share as the exit multiple changes and the discount rate changes. The discount rate in this case is the interest rate, or we could call that the weighted average cost of capital, which we determined a while ago. So for the exit multiple, what will be the intrinsic value per share, that is the equity value per share, as this increases by 5%, or reduces by 5%, and what will be the